So in this video we're going to look at how we find the area of a shape. We're going to start off just by looking at some of our more basic two-dimensional shapes such as rectangles, squares and triangles, and in later videos we will look at also parallelograms, trapeziums or other types of quadrilaterals, compound shapes as well as circles. So just to give you a brief definition of what area actually is, this is the space occupied by a two-dimensional shape. So it's actually the space inside the shape. Previously we looked at perimeter, okay, and perimeter, if we remember, was the outside of the shape. And just to differentiate, we remember that within the word perimeter we have the word rim, and think of the rim of a glass, the outside, and that will help you to remember the difference, okay? So back onto what we're looking at, we'll start off by looking at rectangles and squares. And when we look at rectangles and squares, how we actually find the area within the shape is by multiplying the base and the height. And this is our formula for that. Now, again, just to help you to understand what the concept of area is, if I was to imagine a 1 centimeter square, this is what it would look like. Our units for area as well are millimeters squared, centimeters squared, meters squared, kilometers squared. If we were talking about imperial units, which we can also look at, such as inches squared, it's basically a square where the sides are whatever the dimension is. So in this case, it's a 1 centimeter squared. So each of these sides is 1 centimeter by 1 centimeter. And when we find out the area of a shape, we're basically working out how many of these squares, in the case of centimeters squared, would fit into the shape. So just to give you an idea by looking at a shape drawn to scale. Okay, so as I mentioned previously, the area of a rectangle is simply the base multiplied by the height. So in this case we have a rectangle which is 3 centimeters base and 2 centimeters height. So it was simply 3 by 2 or 2 by 3, doesn't matter what order you multiply them in. And that gives us 6 centimeters squared. And if we're looking at this shape, because it's drawn on square paper which have 1 centimeter squares, we can see that it's accurate. We can see that this formula actually works, because within inside this rectangle we have 1, 2, 3, 4, 5, 6 centimeters squared. And whenever we work out the area of a shape, we're basically saying how many of these squares fit inside it. That's if we're talking about centimeters squared. If we were talking about millimeters squared, they'd be much smaller. Meters squared, they would be much larger. But what you're more commonly going to be asked in your GCSE is shapes that the diagrams aren't actually drawn to scale. Okay, so when we look at rectangles or indeed squares, the area is simply found by multiplying the base times the height. So if we look at two examples where we're dealing with shapes that aren't actually drawn to scale, so we have here, find the area of this rectangle. So we have a base of 7 centimeters times a height of 3 centimeters. So if I was setting my work out, it would just be A equals B times H. And I will point out that within school you may have learnt it slightly differently, such as width times height or breadth times width or something along those lines. Basically, whatever you've called it, it's just these two dimensions which are perpendicular to each other. Okay, I like to think of them as base times height, which you'll see later why I do that, because whenever we look at our other shapes such as triangles and parallelograms, we always refer to the base and the perpendicular height. So it's good to get into that idea of thinking of the base as the bottom of the shape. Okay, and you can turn the page if needs be if it's drawn at a certain orientation. So the base is 7, the height is 3, so 7 times 3, 21 centimeters squared. So again, if this was drawn accurately onto squares like this, and again, if you have square paper available, you could draw 7 centimeters long, 3 centimeters tall, and then count the squares in the middle, and you would see that you would have a 21 centimeter squared rectangle. Okay, but when it's not drawn accurately, this is the formula that we use. If we look at the square, and again, just to keep an eye out, I would know that this is a square without me being told that it is a square, because these dashes, as I've pointed out before, indicate that all the sides are the same. When all the sides are the same here, we know it's a square. So area equals base times height. I would know that the base, even though it's not labelled here, is 5 meters. So again, just to be careful of units, the base is 5, because this side is also 5, times the height, which is 5. 5 fives is 25, and because my dimension here is in meters, my answer is going to be in meters squared. So this, if it was drawn accurately, drawn to scale, would be a much larger square. That would probably be the space of a small room. Okay, so obviously why it's scaled down if we were asked this type of question in a GCSE. Alright, so moving on, that's rectangles and squares, very simply just base times height. We're now going to look at triangles. So slightly more complex formula, not that it's a great deal more difficult, slightly more complex formula for triangles. Base times perpendicular height, and I'll explain what that means in a wee second, all divided by 2. Okay, so the perpendicular height, if we look at this triangle here, just to give you the idea, this is the base, say this is the bottom. The perpendicular height is the height that is vertically up from top to bottom. Okay, if you were given one of these slanted dimensions, the slanted height, don't use them if you're trying to find the area. Sometimes they can throw that in to throw you off, so just be aware of that. Alright, best way to get a bit of an idea of this is to look at an example. So we've been asked to find the area of this triangle here. So we've been given 3 dimensions. Okay, well, we know this is the base. We've been given this height and this height. Okay, well, this is the slanted height, and we're not going to use that. So always remember, don't use slanted height. Okay, we're going to use the perpendicular height. So A equals, so A for area, base times height, perpendicular height, all divided by 2. Okay, substitute our values in. The base is 6, the height is 4, all divided by 2. 6 times 4, 24. Divide that by 2 is 12, and my units is, again, centimetre squared in this case. Alright, we'll do one more example on triangles. And again, I will look at later videos where we look at parallelograms, trapeziums and so on, or other shapes. But again, just to go into things in a wee bit more details, this is a right angle triangle. And there's a couple of reasons I'm going to look at this one with you. It's just to give you that idea of, first off, why we divide by 2. The reason we divide by 2 is because you get this idea best if you were to look at a right angle triangle. A triangle is kind of like half a rectangle. And if you remember from earlier, the area of the rectangle is simply found by multiplying base times height. Well, the triangle is half that. Basically what you're doing is working it out as if it was a full rectangle and then cutting it in half. So that's the first reason I want to look at this particular example. The second reason is, again, just to keep an eye out for this curveball where you need to check the units. So what I've done here is one of the dimensions is in centimetres and the other is in millimetres. Now, sometimes within the GCSE they will have the answer line and the unit specified that they want you to use. So in that case, say the unit on the answer line said centimetres squared, then we would have to make sure all our lengths are in centimetres. If it was millimetres squared, we would have to make sure it's all in millimetres. Well, let's go on the assumption that the answer line has given us centimetres squared. So therefore, this is fine because it's already in centimetres. This, however, would have to be changed into centimetres because it's in millimetres. Now, I will do a separate video in terms of our metric and imperial units, but for now I will just explain that there are 10 millimetres in a centimetre. If you ever get confused on that, if you look at a ruler, from here to here is 1 centimetre. These little small increments are millimetres, so you can see there's 10 millimetres in 1 centimetre. So 90 millimetres is 9 centimetres. I just divided that by 10 to change it. Okay, so now that we've made sure all our units are the same, we just use the formula. Area is equal to base times height divided by 2. The handy thing about a right angle triangle is that we already know it's perpendicular to the base, so this is in fact our perpendicular height. So we don't have to worry about that. So the base is 8, substituting in, times the height, which is 9, all divided by 2. 8 9s, 72 divided by 2 is 36. Again, our units, centimetres squared, and of course you would just write that on the answer line. And again, just to keep an eye out, sometimes they will leave the units out altogether, tell you to choose your units, in which case you can either opt for millimetres or centimetres squared, and sometimes they will give you the units they expect you to use and state choose appropriate units, in which case you have to write the units and that will be worth 1 mark. So make sure that the units are always on the answer line if you have to put them there. Okay, so I will include some examples for you to try at the end. Anything you're unsure about, just feel free to ask.